So this is thank you from everyone who grew up in California. All right, so we'll start off. Basically, we're service technicians and engineers. There's a quote I really like from Dr. Charles Dudley from the Pennsylvania Railroad back in the late 1800s, and he was starting the ASTM, which is a Society of Standards. And he quoted, "A good specification needs both the knowledge of the product's behavior during manufacture and knowledge of those who know its behavior while in service." So I always thought that was good because it shows that technicians' input is pretty important. So we'll start with the presentation. All right, so basically we're going over anomalies in the OB systems that affect technicians. We've basically defined an anomaly as a failure in which a solution cannot be solved using conventional methods. So it's pretty broad. So what does it look like? For engineers, I'm sure you've all looked at this document and see what anomalies look like. For a technician, it looks a little more like this. We can cue the video. So that's how we feel when we come across these. So we have a couple of case studies. The first one, I actually decided to take out the manufacturer's name of the vehicles because I want to be able to drive home tonight. These are just examples, but we deal with these all the time. So the first case is variable cooling fans setting electronic throttle control DTCs. The scenario we have, the mill is on, the vehicle's in reduced power mode. I'm sure you guys will probably eventually start to decipher who the manufacturer is, but I'm not going to say their name. So the mill's on, vehicle's in reduced power mode. The DTCs, which may give it away, are P1221 throttle position sensor, P1271 accelerator pedal position sensor. The possible causes, according to the service manual, are your APP sensor, your throttle body assembly, wiring, connectors, or control module. Anyways, the DTCs, basically, the service information doesn't lead to the variable cooling fan. They do direct the technician to test your powers and grounds. Unfortunately, when you're testing your powers and grounds, you're in key on, engine off, because you got to disconnect it, check it. Your fan's not going to be running, so you're going to have your powers and grounds. And you're going to start it up on the scan tool. Everything will look fine, and all of a sudden your TPS, he will drop out. Your logical conclusion is going to be, well, there's something wrong with that electronic throttle control. The reality of the problem is that the cooling fan is showing up. What happens is the cooling fan shares voltage with the electronic throttle control. So the outcome of this anomaly is unnecessary cost on the consumer. As we all know, because repairs aren't cheap. Your average shop rate is about $100 an hour or more. Anomalies like these can bring unnecessary repair costs into the thousands of dollars without the problem being fixed. Due to complexity of the repair and lack of ability to find the problem, consumers can expect to be without a car for multiple days, maybe even weeks, depending on the workload of the shop. And then, if the problem is not fixed right, then we have what the technicians we consider the evil comeback. And that's when not only do you have a mad customer, but as a technician, you're definitely going to get heckled by every other kind of technician, as well as probably in trouble. But most important of all, it creates an extremely negative view on the entire industry. It's most important to note, though, that a major blame for these issues is put on the manufacturer themselves. Because in the technician world, we can't make mistakes. So when the customer says, why does this keep happening? I don't know the technician that's going to say, well, I'm just not able to diagnose your car. They're going to say, well, you shouldn't have got that car. So, yeah, we did everything right. It's got to be whoever designed that. And it's true too. In the aftermarket, a lot of your customer base comes in and says, what do you suggest I get for a vehicle? Now, all the comfort systems and gizmos and gadgets in the world are great, but when your customer asks the technician, what do you think of this car? Depending on that technician's experience with it, you better hope those gizmos and gadgets were easy to fix. Because when you have limited service information or it's just not there, they're not going to say, oh, well, go buy one so I can work on it for you. So, is this basically limited to one or two technicians that don't know how to do it? No, it's actually very common and among dealership technicians. So what are customers saying who've dealt with this exact anomaly? You take a Google search of this anomaly in this vehicle to find out the forums and the customer pages and what they're saying about this exact scenario. This first person said, I'm looking for some assistance. My 2003, I blanked out the name, has 63,000 miles and has been experiencing the reduced engine power problem. The dealer has replaced a fuel sensor, entire wiring harness, computer, and it still is occurring. The only other thing they plan to try is the accelerator assembly. Any thoughts on whether or not this should fix the problem? I've been a very loyal owner, but this experience has me reconsidering that. It's an anomaly. There. This person says the reduced engine power sensor, you got to remember they're customers, so you decipher what they're saying. On my 2003 keeps activating. I've had it in the shop 5 times. Dealer has installed software updates, but problem persists and is getting worse. They have no idea what is causing this. Factory support has been no help. Looking for solutions. This one, I've shelled out $1,200 for the fuel sensor. I'm still kind of curious what a fuel sensor is. Once again, customer, you gotta decipher what they're saying. Accelerator assembly and wiring harness. Computer was covered under a warranty of some type. After the 4th trip, where they replaced the accelerator assembly, it has been fine for the last 2 weeks until today. Same problem. I won't pay another dime to fix this. Taking it back tomorrow. Any suggestions? So you gotta remember, these people are now so frustrated, they're going to the internet and asking other people with the same problem to see if maybe one of them actually got a fix, because the dealerships, the aftermarket, even the factory support could not figure this out. And this one's great, by the way, because this could not lead you more to what it is. I'm having the same issue. Local mechanics said the code was the accelerator pedal. Put 2 aftermarket ones on and worked okay for about 3 weeks each time. Now the dealer says that they could put on a $380 OE pedal, but no guarantee that it will fix the problem. Big surprise. By the way, the fan clutch sounds like a Tomcat ready for launch, and that is another $800. Are these problems related? Seemed to reduce engine power started back when I noticed the fan clutch starting to go out. I kind of want to meet that technician, because I'm sorry, at that point, it's time to start looking. But so it seems like a simple fix. So what led to this? Why does it happen? Well, misleading information, lack of service information. Service information does not lead a technician to test the variable cooling fan. Weak schematics. The wiring diagrams for vehicles and the service information usually splits it up into groups. Throttle control falls under the engine performance diagrams, while the cooling fan falls under the cooling fan diagrams. There's no place that shows there is a connection between the two. Lack of TSBs. There is a TSB that comes close to pointing to this problem, but leads to checking the wires near the cooling fan for rubbing through. The other thing, there are codes in the system that should have set for the variable cooling fan, but they're not set. That's an anomaly. Why would they not set with a shorter cooling fan? But the other code's set for throttle control. And technicians today, with our training, we have way too much trust in the OBD systems. And a lack of codes being set will keep people from even suspecting it, especially if you know that there are codes that are for a variable cooling fan. And then another big one, beating the clock. Technicians get paid flat rate. I don't know if everyone's aware of how flat rate works. I'm pretty sure you are if you work in the industry. But you have a set amount of hours. Diagnostics, usually you get an hour diagnosis. Once it goes over that, it doesn't matter if it takes you 2 days, you're getting paid an hour of labor. So they're constantly pushed to be quicker because the shop wants you to be more efficient. So if shops now expect 150% efficiency. So even what the guided labor guide says, they expect you to be 150 times efficient. So when a technician gets paid an hour of labor for a diagnosis, but that diagnosis starts to take over an hour, it's creating an environment of cutting corners and skipping important guidelines. I'm presented with the choice of, I could cut this corner and I'll have the money to feed my children, or this person, I have no idea who they are, but I have to be honest with myself, so I'm going to go with them. Unfortunately, a good majority, as we are seeing in our industry, choose the latter. The bad one. So there's a lot of corner cutting. What the major contributing factor to this really is lack of technician education. Anomalies happen and it's no one's fault. But the lack of the ability to find them, pressure leans on the technician from his boss, from the customer, which then refers to technician's never wrong, so it's got to be the car. And these anomalies happen, so sometimes it's a problem that you can't find. Another thing, there's no driving force for them to learn. They do not realize the advances in OBD2. You'd be surprised at how many think it's the same as it was in 1996. That's scary. But it's a case of they don't even know that they don't know. So many of today's technicians are not trained to solve complicated problems. They're trained to read a code, follow a trouble tree, and replace parts. Dealerships are doing it too, where technicians, they're not hiring top quality technicians. They say, if that doesn't fix it, call the hotline. They can fix it, because the guy over the phone, far away, is somehow able to find it better. Educators have been trying to push for better education training, but it is an industry-wide effort. It's going to take help from all sides of the spectrum. And for the next case study, Steve.
Good afternoon. My name is Steve Caruso. I'm both a mechanic, educator, instructional designer. So I've got a little bit of a different take on this matter. This next case study is going to be for a failing emissions. In the state of California, we do emissions testing both on a dyno with OBD2. And that poses two problems. This next case study I'm going to show you, the car failed emissions, but passed all the OBD2 monitors. This is our regulatory phase-in. If we take our CCR 1968-1 and 68-2 and put it on a spreadsheet, this is what it's going to look like. In about the center of the screen, over in this area for our rear oxygen sensor, and for the people on the other side, over in here, you'll see that we only have limited activity in 1998 for these vehicles. This car that I'm about to show you is a 1998 Toyota Camry. And by the way, I'm not picking on Toyota. Toyota, you have very fine cars, so please don't take offense to this. Everybody has these anomalies in the industry. This is just something that that I personally had a problem with and I wanted to bring up. So this was a 1998 Toyota Camry 2.2 liter engine, California emissions. There was no codes in this car. All the monitors had passed. And for the tailpipe emissions, it was 7% CO coming out of tailpipe. Now this was measured on a California Bar 97 gas analyzer on a dyno. One of the problems that this car had was that it was taken to many different shops. We were one of the last shops to look at this. The different shops have put on PCMs, catalytic converters, and oxygen sensors. This is a waste of money and customers' time. There was literally thousands of dollars spent on this. Some of it was subsidized by the state of California in their consumer assistance program. Lucky for them. But what was happening on this car, no matter what happened, we were still getting 7% CO coming out of the exhaust. And there was no codes. We would assume that if it's running as rich as it is, and the smoke was black coming out of the tailpipe, we would have some sort of codes. But there was none. So at the time, the consensus was that the PCM was the problem. Why would the car run rich and no code stored? Obviously, there had been a malfunction in the OBD2 system. There wasn't any. The OBD2 system was functioning properly. So the engineers, you did a great job. The problem is that there was an anomaly that was on this vehicle that nobody knew about. We checked the fuel pressure specs because at 7% CO, you'd have a pressure regulator that could be sticking. It was fine. The powers and grounds were looked at. We used a lab scope to check for any AC ripple or any deviations in the grounds. There was none. The engine was in perfect operating condition. There was no low compression. It was not overheating. The thermostat was operating properly. So we thought we did our diagnostics correctly. And as far as we knew, we were. The front oxygen sensor, as I stated, was already replaced a number of times. So for the third oxygen sensor, we knew it was still good. It was capable of working. But it was still staying pegged at anywhere between 800 to 900 millivolts. The injectors were staying open. We used another test vehicle and verified that the injector pulse width was a little bit wider than it should have been. This is why we kept saying it had to have been a PCM problem. So again, everything was operating the way it should. There was no diagnostics in this. And now as an instructional designer and an educator, we would always look for our trouble codes or any other major codes of that nature, or any other tidbits. Some of the manufacturers put it in. Except at this point, most of you are still looking, how can we have 7% CO, no codes, and all monitors have run, and a good PCM? Well, it happened. So I'm going to review very quickly. 7% CO with a 5-gas analyzer. O2 was staying pegged at 900 millivolts. There was no skewed PIDs, except for the rear oxygen sensor. It was at 100 millivolts. But as most of us know, the rear oxygen sensor on a 1998 car was just there for catalyst efficiency monitoring. Well, it did a little bit more than that. It was actually there for final fuel trim. Nowhere in any of the books did we talk about final fuel trim. The sensor, according to OBD2 regulations, was operating properly. There was never going to be any codes because it just needed to be plugged in and tested for conductivity. We did a massive search since I was the one that was doing the repairs on this vehicle. I checked the internet, I checked online sources. At no time did we find anything on rear fuel trim. Up until 2001, 2002 was the first time Toyota mentioned something like this. Well, this was the anomaly. In the end, we still looked around and we wondered, why was there no codes for the oxygen sensor or even for the fuel trim? Well, according to regulations, the OBD2 regulations, the regulatory phase-in that I showed you, the rear oxygen sensor was only tested when it's cold on first startup. And when it was cold on first startup, when we hooked it up to a lab scope, it did start to oscillate. But it was a deteriorated sensor. So it slowly petered down to what would be called a near shorted position, 100 millivolts. And it stayed there. According to the regulations, it passed its test. There was no codes for this. It was fine, and it was plugged in. The bias voltage was being held low, so it knew that it was plugged in, no codes. Why was there no codes for the final fuel trim? Well, according to 1968-1, the only codes was for the primary oxygen sensor. There was no codes for the secondary oxygen sensor on final fuel trim. Anomalies. This is what's hurting our industry. The simple fix was to replace the oxygen sensor. We replaced the oxygen sensor, ran it on the dyno, fuel trim values came down, and the car now passed. A simple fix, but it cost many thousands of dollars. And it was something that could have easily been avoided if we had some proper information. We aren't blaming anybody on this one because the car was doing exactly what it was supposed to be doing. We had an issue with the way the information was delivered to us. It wasn't where we needed it in a timely manner. We understand now that that car should have easily have flagged a code. If not, the technician, myself and others, should have noticed that there was a problem with that rear oxygen sensor. Anytime you have 7% CO, black soot coming out because it's running rich, and an oxygen sensor that's hitting near 0 volts or 1/10 of a volt, indicates a problem. And we know that now will solve and will cause problems, and we now have that ability to look at it. But the problem is getting the information out.
So what do we do about these anomalies? Here's some of the outlets that bring to light some anomalies. Your OBD clearinghouse is well as California's Bureau of Automotive Repair, which is actually discontinued with their Appendix J. These deal solely with emissions and IM testing issues. J1699 Task Force is great. Deals solely with communication anomalies and testing your OBD systems. So technicians rely on inputs from sources like IATN, Identifix, and SureTrack to help lead to answers for anomalies. These are great tools, provide great insight into possibilities, but they rely solely on input from other technicians. So they can only be as accurate as the technicians who shared them. One example I like, Identifix has, you put in the code, and then it has a list of what technicians have done to fix it. And then it tells you how many times that fix has worked for. But one of my favorites, that's a prime example, is the evap leak. You have over 100 hits saying gas cap. So what I want to know is how many of those technicians for a $15 gas cap actually went and drove that vehicle and got the evap monitor to run after letting a cold soak happen to verify that that was the problem. I want to know how many of those technicians 2 weeks later, after they put in the gas cap was the fix, that car came back with that same light on. So it's only as good as the technicians who put the input. So what we'd like to do is create a database that will unite all anomalies, find resources to get these to technicians and educators in order to better prepare technicians, and possibly form a way of verifying anomalies of authenticity. Because going off hearsay or what other technicians have done can't always work. But most importantly, what's really important is a collaboration, not only between OEs and aftermarket, but between technicians and engineers to find a way to find these and verify these anomalies. Because I can tell you just in these last 2 days, some of the presentations, from a technician's point of view, you see some things and go, that's going to hurt later. I don't want to put anybody on the spot, but if you feel like maybe your presentation was one of the ones that may have had one, feel free to talk to me later. I could point it out. But we can't do this alone. We're asking on everyone here to see the benefits of this and help, because collaboration can be more effective than competition. Yes, we're all from different companies, and everyone has the competition in a way. But when you think about it, what's worse? Getting the information available to aftermarket technicians and that customer gets their car fixed right, quick, and they're happy with their car, and those aftermarket technicians say nothing but good things about the car,